decades to centuries since this level of bombardment, and all forecasts indicate the maximum to intensify for years to come, likely decades more. But do you actually know what a cosmic ray is? Voyagers. That's the best name for their lifetimes, as they spend eons zipping through space, missing most of everything, sometimes even passing right through a galaxy. They are produced in powerful events like supernova blasts, cosmic jets like quasars and blazars, and even in wild orbital binary stars on close approach. These energetic events in space can energize and accelerate particles to nearly the speed of light, which traveled through the cosmos, and the one we're riding here seems to have found the Milky Way. These are coming from every direction and pound the upper atmosphere every square meter every second. So as we see the particle cascade, which truly happens in the blink of an eye, know that the initial particle blasts up high out every moment from just about everywhere above you. So what sort of particle has been on that journey that ended in Earth's atmosphere?
Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Engine ignition and liftoff of the Delta II rocket with the Mars exploration.
At 1 minute and 30 seconds, we're in orbit around Earth. As you see, we're starting to drop away some of those airlit solids. Once those airlit solids fall back away, they get recycled. They get picked up. Once our first stage burns out, we're going to let that go. We're going to light our second stage. Once we light our second stage, we let that first stage fall back to the ocean. It becomes an ecosystem for the fish. We light our second stage. At this point, the spacecraft has very little stability, so we're going to spin it up. We spin it up to about 12 RPM, more or less like a quarterback that throws a nice tight spiral. We're going to get really good flight through the air. We'll light our third stage. This puts us on a direct trajectory to Mars. Months later, here we are, traveling at 16,000 miles per hour toward the surface of Mars. We lose our crew stage because we don't need it anymore. It's pointed us directly at Mars. We're ready to go. We're going to hit our landing site. We're traveling at 16,000 miles per hour, and we hit the upper atmosphere of Mars. When we hit the upper atmosphere of Mars, the friction as we come through literally burns a hole in the upper atmosphere. The heat shield in the front of our rover gets to about the surface temperature of the sun. So we're going to start what I like to call reverse origami. We're going to pull up a parachute. This is a supersonic parachute, and that's going to start changing our angle of attack from being directly in to being more vertical with the surface of Mars. At this point, we're going to slow down to around 300 to 400 miles per hour. We're going to lose our heat shield because we don't want that heat to come back into our vehicle. And we're going to lower our lander more or less on a shoestring. Once we find the surface, we blow up the power, cut the cord, and bounce. And we bounce. And we bounce. Now, we're going to deflate the airbags. So the vehicle senses that we've stopped, we deflate the airbags. The next thing that we're going to do is we're going to open up the solar rays, and if you don't mind, I'll watch too. We got one more thing to do. It's one more part. Okay, just get over that. Once it gets over center, oh, okay, all done. Whew. Things that you want to do when you've landed in a new place is find out where you are. So we're going to take this beautiful image, and we're going to start transmitting that back to Earth.